Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner's burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC. This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, once again. Thank you for joining us on the Space Nuts podcast, episode 201. And thank you to all those people who sent us good wishes about achieving 200 episodes. The three of you must have listened intently to know that it was our 200th episode. We do appreciate the feedback here. A few people on various platforms sent us some nice notes. Joining me as always is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. How are you going? Good to hear your strident voice again.
Thank you, sir. Yes, good to hear yours too. And I hope you're well. Still in isolation, I assume?
Yeah, that's right. But all going well. We're, just working from home, carrying on as you do.
Yes, absolutely true. And we're starting to see the rules being relaxed in New South Wales, so people are starting to venture out. I think there's most people are being very cautious, but a lot of people taking advantage of the new opportunity to visit family and friends on a very, very limited basis and maintain social distancing, etc. But it looks like whatever we've done to curtail the spread of this disease has worked very well in Australia, which is, you've got to tip your hat to the authorities. I know it was a hard sell, but most people have taken notice, and we've got ourselves down to less than 1,000 active cases in the country now, which is just fantastic.
Indeed it is. And fingers crossed that we'll keep going in that direction. And, our thoughts are always with people in other parts of the world where things aren't going anywhere near as well.
Yeah, I was looking at the statistics in the United States today, and I'm gobsmacked, to be honest. I don't want to dwell on that, but some of those states in America are really in a bad way at the moment. But it's different for every country, different rules, different systems, different capabilities seem to really be a factor as well. But here we are doing what we can to try and stem the tide. Now, Fred, we are going to talk about quite a few exciting situations that have arisen, one of which we've only been able to talk about now because it's been the subject of an embargo, and that's the European Southern Observatory's major announcement about a black hole. Now, you and I can talk about this because it's post-embargo, but this has been sort of kept top secret right up to Wednesday night, which has been rather extraordinary. And another fascinating yarn has to do with the Ice Moon of Europa, which orbits Jupiter. And we had a space probe out there 20-odd years ago taking selfies of Europa and Jupiter and everything else that sort of floats around out there. It's 20-year-old data, but now we've been able to use up-to-date technology to take another look at it, and I'm guessing they've found some interesting things. Speaking of Europa, we've had a question from Adrian Crawford, who has asked a specific question about Europa, so that'll dovetail well. And Monique wants to talk about mining on the moon. The moon's been in the news this week. So many different countries certainly want to go back there. Trouble with the moon is nobody owns it, and so this is going to turn into a scrum, I reckon. So we'll look at all those issues today on the Space Nuts podcast. But first, this very exciting announcement by the European Southern Observatory about a black hole, which, as I understand it, turns out to be the nearest one to Earth, and it's not Sagittarius A.
Exactly, that's right. Sagittarius A, the supermassive black hole at the centre of our galaxy, that's 25-ish thousand light years away. We see it in the direction of the constellation Sagittarius, but it's behind all the dust and murk out there, but can be detected by radio waves, which is why it's called Sagittarius A star. That's the name of the radio source. So this is a different story altogether, and it kind of has echoes, Andrew, of something we were talking about probably about 3 or 4 weeks ago. The idea that there might be many black holes out there which don't reveal themselves by anything other than the way they disturb the orbits of stars nearby. In other words, they don't have an accretion disk of swirling material that's plummeting into them and causing X-rays and radio waves to be emitted. They're just quiet, quiescent is perhaps the technical word, black holes sitting there doing nothing but minding their own business, but actually having a gravitational effect on nearby stars. And that is exactly, that's exactly what this story is about. It comes from the European Southern Observatory. And actually, this discovery was not made with one of their giant 8.2 meter telescopes of the VLT, the Very Large Telescope. It's actually one of the smaller ones, a 2.2 meter telescope at La Silla, which is one of the two main observatory sites that the European Southern Observatory runs in Chile. So astronomers using that telescope have been analysing the motions of a star system, which is only 1,000 light years away. It's basically in our galactic neighborhood and easy to see. In fact, this star system can be seen with the naked eye. It's in the southern hemisphere constellation of Telescopium, the telescope, which is all very appropriate. Yeah. And I think it's scientists in the Czech Republic and at the European Southern Observatory itself who've done this work. And the really nice part of the story is that it all came as a surprise to the investigators. One of the scientists says, "We were totally surprised when we realized that this is the first stellar system with a black hole that can be seen with the unaided eye." And that's big news. So what we got here, we've got this star whose name is HR6819, very elegant name really for it, but it's a double star. Okay, so that means a binary system, one star orbiting another.
Yeah,
and this program that these scientists were working on was a study of double star systems, but what they were amazed to find was that their observations demonstrated that this was not just a double star, not just a binary pair going around their common center of gravity, that there is something else in the system. And basically, one of the two visible stars orbits an object that is not seen every 40 days. And actually, the second star kind of orbits at a much greater distance from this inner pair. So what you've got is a mystery here. We've got this two stars, one of which is orbiting the other, but one of them is actually orbiting something else as well, and that's the invisible bit. So another of the co-authors, Dietrich Bader, who's at ESO, he says the observations needed to determine the period of 40 days had to be spread over several months. This was only possible thanks to ESO's pioneering service observing scheme, under which observations are made by ESO staff on behalf of the scientists needing them. That's a mode of operation that actually many astronomers in our country, in Australia, have used since 3 years ago. We became a strategic partner of the European Southern Observatory. So that service mode observing means that if you need observations over a long period of time, you can't go and spend 2 years sitting in La Silla in northern Chile. So you get the local staff there to do the observations for you, and that's how this has been brought about. So the bottom line, Andrew, is, and once again, here's a quote from one of the co-authors: an invisible object with a mass of at least 4 times that of the sun, which is what this had to be, it can only be a black hole. It can't be anything else. And so that is the smoking gun. The orbit of this, the nearer star to the black hole of this pair, spinning round once every 40 days, around something 4 times as massive as the sun, has to be a black hole. And it is the nearest. And the conclusion is a really interesting one, because let me read from the ESO press release, if I can, Andrew. Astronomers have spotted only a couple of dozen black holes in our galaxy to date, nearly all of which strongly interact with their environment and make their presence known by releasing powerful X-rays. But scientists estimate that over the Milky Way's lifetime, many more stars collapsed into black holes as they ended their lives. The discovery of a silent, invisible black hole in HR 6819 provides clues about where the many hidden black holes in the Milky Way might be. There must be hundreds of millions of black holes out there, but we know about only very few. Knowing what to look for should put us in a better position to find them. And this might be...
Sorry, go on.
Yeah, just to say, it might be the tip of a very exciting iceberg. This could be the first of many that are found by this technique.
So this is not only the discovery of the nearest black hole to Earth, it's also the discovery of a way of finding them because of the way we found this one. Is that what they're saying?
That's exactly right. Yes, that's right. And in fact... Sorry, go on.
I was going to say that's a giant leap forward, really.
It is a giant leap forward. I mean, we actually talked about something similar to this probably 4 or 5 months ago, another similar discovery. But I think this one is the one that really clinches it, that we've got this way of discovering black holes by looking closely at the way stars, stars in binary systems actually orbit. It's a very powerful technique, and I think you and I will be talking about it a lot more over the years.
Yes, I'm surprised they've only found, a dozen or so in our immediate vicinity over the years. But as we have discussed, these things are very elusive. But it now seems that they've revealed to us a way of now finding them, and we may be finding them in their hundreds or thousands into the future. We've also talked in the past about the size of black holes. I think you did allude to the size of this one, but just give us a reminder. How big is this one, did you say?
Yeah, 4 times the mass of the sun. So,
okay, and where does that sort of sit in the black hole sizing chart?
It is, Andrew, and remember where you heard this first, it is a standard black hole.
That is, so we haven't really had a definition for them, have we?
No, in the trade, in the world of astronomy, we refer to them as stellar mass black holes because their mass is about the same as a star. And, you and I, again, have talked about this before. We find black holes in basically 2 different categories. Stellar mass black holes, kind of like this, maybe up to 10 or 20 times the mass of the sun, and the supermassive black holes, which are up to 10 or 20 billion times the mass of the sun. So, and very little in between. And finding new objects in between is another of the challenges, what you might call intermediate mass black holes, because they must be out there. And we think that they lurk principally in the centers of globular clusters, those things that are probably the remnants of galaxies that have been gobbled up by bigger galaxies like the Milky Way. So there is a picture building up here, but giving astronomers a method of finding stellar mass black holes that are not active, that they're not emitting X-rays because of their accretion disks, that's a really powerful step forward. And it comes about, I have to say, once again, because of the science of spectroscopy. You're looking for that Doppler wobble, the thing that reveals planets around stars, the idea that a planet pulls a star slightly backwards and forwards and reveals the presence of the planet. The Doppler-Webbel technique in use since 1995, but this is an extension of that in a way. It's a kind of Doppler-Webbel technique, but for things much bigger than planets, for black holes. So it's a very powerful way of finding them.
Yeah, we ought to submit a paper or an application or whatever it is we do to whoever is in charge of naming objects and suggest that these be called standard mass black holes. We ought to do that. Do we know an astronomer who's got contacts that might be able to do that, Fred?
Yes, me.
Yeah, I was going to suggest that. This would be the International Astronomical Union, wouldn't it? We'd have to go to them.
Do that. Yeah, and they would say, well, that's very nice, but we've already got a name for them. We call them stellar mass black holes.
Yeah, that doesn't tell you much, though.
I think as far as Space Nuts is concerned, they're standard black holes, Andrew.
We'll call them a standard black hole from here on, if we remember like to do so.
Drink. Yeah.
Yeah, that's right. Yes. But that varies from country to country too. Yeah, all right. This is fabulous news. So, there'll be a heck of a lot more to learn. And this is probably going to get some chins wagging for a little while, finding a standard black hole so close to Earth. And did you say it was observable with the naked eye? Was that what I heard?
Yeah, that's right. It's visible to the naked eye. I don't have a note of its exact magnitude, which is the technical term used for the brightness of stars. It's certainly, it's probably about fifth or sixth magnitude, which is round about the limit of visibility with the naked eye, maybe fifth magnitude.
So would this be a good candidate for a photograph?
Oh, yeah, there'll be many of those. But, of course, all it shows up as in a photograph is a single point of light because it is you don't see any of this structure, the binary structure of it, because that's only revealed by the fact that you can watch the way the stars move around with a spectrograph, checking their radial velocities, as we call it. This star, it will be in any image taken of that part of the sky with modern digital cameras, and it'll be quite bright because it's a naked eye star. But it won't show anything different about it to the casual looker. It's only when you start analysing the motion of the component stars that you realise that there is something very, very special locked up in this.
Yeah, all right. It is HR 6819. Remember that. Write it down.
Remember that number.
It's a wonderful discovery, and I'm sure we'll get to talk about it again real soon. You're listening to Space Nuts with your host Andrew Dunkley and the good Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Once again, shouting out to our patrons who support the Space Nuts podcast with a few dollars a month into the kitty. We appreciate your support and we greatly encourage it too, but it's not mandatory. But if you would like to investigate the possibility of being a patron, you can do so on the Patreon website, patreon.com/spacenuts. And if you think that's something you'd like to do, great. If not, that's fine too. We are not going to hold a gun to your head or a stellar mass black hole or anything like that. Patreon or a standard black hole. Patreon.com/spacenuts. And we would like to thank those of you who are chipping in to keep this podcast alive and well. We greatly appreciate your support. Now, Fred, let's move on to the next topic of interest. And this one is very interesting too, because this dates back 20-odd years when Galileo was hanging around Jupiter, chewing the fat, taking a few pics. And they did take photographs of Europa, the ice moon. But here we are 20 years later or thereabouts, and they've reanalyzed some of the data because, the photographic technology we have today is much more advanced. And I'm guessing, voila, they've come up with a little bit more detail about this amazing little world.
Indeed, that's right. And so this is not accidental. It's not just people saying, "Oh, we'll go and have another look at those data from Galileo." This is all about preparing for the next missions to Jupiter's moons. There is one called the Europa Clipper, which I think is now approved. I need to check that within the next few years. There's another mission called JUICE, the Jupiter Icy Moons probe, which I think is also on the stocks.
I love the name of that one. Juice.
That's great. Juice, yeah.
Jupiter Icy Moons.
So these are missions that will give us much more detail about the icy moons. And of course, as is well known, and it relates to the question that we're going to talk about in a few minutes, Europa is one of the moons of the outer solar system that has this structure with a rocky core, a liquid water ocean over the top of it, and then over the top of that, a solid ice crust. Europa is special in that the ice crust is probably one of the youngest surfaces in the entire solar system. It's estimated to be between 40 and 90 million years old. Now, that sounds like a long time, but that for a planetary surface or the surface of a world like Europa is very, very young. The cratered surface of the moon, for example, the southern hemisphere of the moon, which is heavily cratered, is more like 3.8 to 4.2 billion years old. It dates from a time when objects were hurling through the solar system and bashing into everything, what is called the late heavy bombardment. So the surface of Europa is not like that at all. In fact, there are no discernible craters on it. But what there are is other markings. And the classic Galileo spacecraft images from 1998 show these. Basically, they show that a surface that is crisscrossed by brownish markings, many of them very linear. And those markings, in the original images, it's not really possible to distinguish what you're seeing. They just look like brown markings. Now, that brown color is thought to be what happens when you've got a briny liquid, almost like seawater, filtering up through the ocean beneath, and then being irradiated by the sun's radiation. Experiments were done a few years ago that showed that if you've got water that's rich in salts and minerals, and you irradiate it with ultraviolet light and the kind of particle bombardment we get from the sun, it turns brown, just like these streaks. So, but those original images didn't really show much detail, and that's why this is such a great story, because these. What we're talking about today is a reanalysis of those images by a team actually at NASA's Jet Propulsion Laboratory, led by planetary geologist Cynthia Phillips, and that is, a fantastic project to bring modern computer algorithms to bear on images that we looked at and said, yeah, they're great, fantastic stuff, and then put away for 22 years. And what they've done is they've shown that the terrain on Europa is not just an ice covering with a few black-brown streaks on it. It's got all kinds of variations in it. So the resolution's quite fine, revealing things as small as 460 meters across, thereabouts. And the detail is now, I think, quite staggering. There is, on the Jet Propulsion Laboratory website, there are some of the reprocessed images. And there are 3 different kinds of terrain that have been identified, which weren't really recognized before. And I guess the first is what's called the chaos terrain. And that sort of tells it like it is. It's like just lumps of solid material, often colored brown, which looks just like you've taken a liquid, filled, take a glass bowl, fill it with ice crystals, which kind of then put it in the fridge so they all partly freeze over, and then sort of stir it up. So these ice cubes rather than ice crystals, but they all tumble all around. We've seen something similar, Andrew, on the dwarf planet Pluto.
Yeah.
Right at the edge of Sputnik Planum, there's exactly this same terrain. And the mission scientists for the new Europa projects think that this chaos terrain on Europa comes about because of exactly that the surface is being fractured, remembering that there are tidal forces from the planet itself that are pushing and pulling this surface. And you get the stuff breaking up into relatively small chunks, which are then tipped around just like these ice cubes and giving this essentially what's called chaos terrain. Two more different features have been recognized. Both really interesting and similar in that they're both long linear features, maybe a few kilometers wide, a few tens of meters high. The ridges, anyway, a few tens of meters high, but thousands of kilometers long. So the two different things are ridges, which is where, as I've just explained, you've got a long ridge of material, just a few tens of meters. I think they were talking about 100 meters or so high, which are probably brought about when two kind of plates of ice compress together. And so you get a pushing up of the material as they collide, remembering that this surface is kind of in motion all the time. Yeah. And that contrasts with what they call bands, not rock bands or anything like that, but bands of a different color. These are the opposite. These look as though they're where two plates of ice have stretched apart and ice has grown in between them, because what you've got is a broad region, it's probably tens of kilometers wide, which is very, very smooth with a kind of ridge on either side of it. It's a bit hard to explain these or to describe these in words, but it's worth having a look at the pictures, the reprocessed images of Europa, which is the buzzword to put into the Jet Propulsion Laboratories website, jpl.nasa.gov.
Okay. How big is Europa?
It is bigger than our moon, if I remember rightly. It's not the biggest of the Galilean moons. I don't have the number of kilometres off the top of my head. It's very easy to find. The biggest of Galileo's of the moons of Jupiter, actually, the biggest moon in the solar system is Ganymede. But Galileo himself, not the spacecraft, the astronomer, discovered these four large moons: Ganymede, Europa, Callisto, and Io. Io is the smallest. Ganymede is the biggest. So there you are. Europa is between Ganymede and Io.
And the beauty of them is that if you've got, a half decent pair of binoculars or a half decent telescope, you can actually see these from your backyard. I think I remember years and years ago being able to do that because I can't remember the circumstances, but Jupiter must have been in a good position for us to observe, and got some amazing photos of the moons orbiting Jupiter with the naked eye, and that's just such an amazing thing to be able to see from such a vast distance.
So Jupiter's coming up to be very favourable now for observing with small telescopes and binoculars. It's rising late in the evening, and it'll sort of rise earlier until eventually it's what we call opposition, where it's in the sky all night, and that's it kind of at its closest. But yeah, binoculars just about show Jupiter as a disk. You really need the higher power end, which is like 10 magnification or thereabouts. The problem with those is holding them steady. Oh yeah. If you can fix them on something, but they would potentially show you the moons of Jupiter. A small telescope is much better, and especially if it's fixed on a stand or something, then you can really see from night to night the way these moons change in position, which of course is what Galileo noticed early in 1610, and set the cat among the pigeons because it was clear that not everything rotated around the Earth.
Yes.
Revolved around the Earth.
And didn't he get into trouble for that one?
He did. He got into trouble, yes.
Yeah. Okay, so we've reanalyzed the data and we've made all these discoveries and we've got much more detail about Europa. I think it would probably be a good idea to just dovetail straight into the question we have about Europa
that's great.
Adrian Crawford. Adrian writes, "Hello, Space Nuts. I had a question I didn't know if you wanted to answer." No, we don't want to answer anyone's question. Is an ocean planet possible? Well, we actually tackled that a week or two ago. So we've answered the question. And I think I remember you saying, Fred, that the Earth was, in fact, an ocean planet at one stage. But then he goes on to ask, is it possible that there is ocean life on Europa, Jupiter's moon? I was just curious if you guys knew the answer to my questions. Just want to say that I really enjoy listening to your podcast and I hope you continue on with your awesome work. Thank you, Adrian. That's lovely of you to say. Fred, do you think that Europa, I think, has been identified as a very potential candidate for containing life, as has Enceladus, I think.
Yeah, that's right. Exactly.
So, I think the answer to the question is yes, but I think we ought to elaborate a bit more on that.
Yeah, no, and it is a great question, and you're absolutely right, Andrew, in that this is perhaps one. Europa is certainly up there among the top 2 or 3 candidates for finding living organisms elsewhere in the solar system. The problem is, how do you find them? Because if you've got a global ocean with a global ice layer on top, which might be 20 or 30 kilometers thick, you do have to worry about how you might probe down to find out what's going on.
Well, first thing you do is you rent a space trawler.
You certainly need that.
Yes.
And maybe a space icebreaker as well.
Yeah, probably.
There are ethical questions. You don't really want to go and smash up the ice on Europa. The Europa, I'm pretty sure I'm remembering correctly, has shown evidence of plumes of ice coming from the surface, exactly as we've seen with Enceladus, the moon of Jupiter. And of course, the Cassini spacecraft flew through the plumes of ice. And told us what's in it, and revealed all kinds of very intriguing things. Molecular hydrogen, which suggests that the water has been in contact with geothermal vents at the bottom of this ocean. There are minerals in it, all kinds of organic materials, all of which suggest that certainly for Enceladus, there may be processes in place that would give rise to living organisms in the bottom of the ocean, a bit like the hydrothermal vents we find here on Earth. And so knowing that Europa has a very similar structure to Enceladus, it's actually nearer to the sun, so it's a little bit warmer, although the surface is still in the minus 150s, I think, or something like that, 160s. It does suggest that maybe there is potential for finding living organisms in the oceans of Europa. And one way of doing that would be to do kind of what Cassini has done on Enceladus, to send a spacecraft. And I think the Europa Clipper, I think, is designed to do this, to orbit the moon of Europa and actually fly through plumes of material being released from Europa's poles, and analyse that. Because what you've got there is it's a free sample of the ocean. Yes, it's frozen, it's just ice crystals. But if you can analyse those ice crystals, you can find out all kinds of things about the environment that they came from.
And save a lot of money on an icebreaker, which you won't need.
Yeah, that's right. Exactly. Although, remembering my conversation with Linda Spilker, who was the Cassini mission scientist, I talked to her last year because she was over to give some talks towards the end of the year. She's working on something called EELS, which is And Enceladus, I'm not sure what it stands for, but it's basically a thing shaped like a snake, which is robotic, and you drop it on the surface of Enceladus and it finds its way down the cracks in Enceladus's ice and has a look in the ocean of Enceladus to see what's down there. Maybe you could do something with Europa that's similar. Call it.
That's a great idea.
Yeah. So I think one of the reasons why people are concentrating on Europa at the moment is it's much nearer than Enceladus. It's a much quicker journey to get from Earth to Jupiter than it is to get from Earth to Saturn. And so we might find results coming sooner, although, of course, there are plans to revisit Enceladus and have a look there as to what's going on too.
Okay, it is interesting. Are you confident that there could be life in the waters of Europa?
Excuse me.
I think I've done this to you 2 weeks running now.
No, it's all right. It's okay. And look, I think there's a really good chance that we'll find stuff that might be quite different from what we have here on Earth, but would still be classified as living organisms. I think it's unlikely that we will find fish or crabs.
Shrimp, brine, nothing.
Prawns. I had prawns for dinner last night.
Prawns,
yeah. But the idea of microbial life, my guess is that we're going to find within the next decade that, yes, microbial life does exist elsewhere in the universe, simply because all the signs point to that, but we haven't found it yet.
Yeah, so the Drake equation will, change if we find life on another world beyond our own. So just in case someone brings that back up again. When's Europa Clipper due to get there?
I don't know. And I don't know whether they've even got a launch date yet. I need to check up on that. Let me see if I can do that now, Andrew, just to give you an answer to your question.
Yeah, I was going to look into it as well. And
let's take that on notice and talk about it.
See if we can find out for a future date.
Yeah.
All right. Yes, Adrian, the potential does exist for life on Europa, the ice moon of Jupiter, and potentially Enceladus as well. And just as a final sort of statement on this, Fred, are there any other life candidates in our solar system?
Well, the other one, apart from the two we've mentioned, the other really strong candidate is Titan.
I thought so.
You knew what I was going to say there.
Yeah.
The biggest moon of Saturn, the only moon in the whole solar system with a thick atmosphere, and this curious, landscape of lakes and seas made of liquid natural gas with rocks that are made of water ice. But once again, there is an ocean underneath that water ice. So all bets are off with that. You could find anything on Titan. You could find microbial life that lives at minus 190 Celsius in a lake of liquid natural gas that breathes hydrogen and eats acetylene. That's one of the ththings that's been proposed. That would be extraordinary, just extraordinary. A non-water-based life form.
Yeah, and again, we want to do potentially some sort of test to see if it exists in the same plane as life on Earth, or if it's a totally independent and self-evolving entity. That's let's just go 2 leaps ahead. We've already discovered life beyond Earth. Is it the same as life on Earth?
Has it got the same genetic origins?
Yes, exactly. That's the next big question.
Big question, yeah.
But let's not get too far ahead of ourselves. But thank you, Adrian, for the question. Potentially, yes, is the answer on both points. We answered your question about water planets last week. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments, and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
And hello to all our social media space nutters who follow us on Facebook, which you can do at facebook.com/Space Nuts Podcast. You can also join the Space Nuts Podcast group, which is a group of Space Nuts listeners that talk to each other on that particular platform. And we're getting new members every week. And I think there's somewhere around 1,000 people in both groups, which is just fantastic. And if you're a YouTube follower, we are there. We are on Instagram. And, of course, we've got our own website at bitez, bitez.com/Space Nuts, where you can catch up on episodes as well. You can also go to the Space Nuts shop, which is getting more and more goodies into the shelves. So, you can take a look at all of that. And, of course, that's one of the several platforms where you can post questions to us as well. Now, we have a question here, Fred, from Monique in Sydney, who is asking about the moon. I have a question that was actually put to me in a discussion about the mining of the moon. If we're planning on mining of the moon, will the amounts of weight being brought back into our solar system, A, affect the mass of our planet because we are accumulating weight that wasn't already found on the planet, B, have some kind of effect on the rotational position of our planet, and C, how would they even think about bringing these mined goods back down to Earth, as it is already quite a dangerous mission getting humans back into our atmosphere. Thanks for your wonderful podcast. I have 7 episodes left before I'm completely caught up, and I plan to start again. Oh, that's great. Awesome. You might want to tell us what happened. But that's Monique's 3-part question about mining on the moon. Now, we have touched on this before, and the moon is in the news this week because there seems to be a new space race to get back there, and that involves the United States and China and India and Japan. I can't think of the players involved, because the moon is being looked at as the platform for a Mars mission. But the discussions surrounding the moon in terms of potential mining exploits have certainly been around, haven't they, Fred?
They have, and it's interesting to reflect on what they might find on the moon that's useful. Let's go through Monique's questions, because that sort of lets us talk about these things. So, if you're planning mining on the moon, what are you going to look for? And the one that I suppose is high up in the popular imagination is the idea of mining helium-3, which is an isotope of helium. There's not much of it on the moon, but there's virtually none of it here on Earth. But it could, and this has not yet been proven, but it could form the basis of clean nuclear energy. It would allow you to do something called nuclear fusion in a manner that doesn't release dangerous radiation. So you could have a desktop nuclear reactor. That's certainly the dream of science fiction enthusiasts, and I think there's some physics behind it to support it as well. Helium-3 mining, if that does happen, would have to come back to Earth because that's where you want to use it. But the amounts that would be being mined are microscopic compared with either the mass of the moon or the mass of the Earth, and that would be true of anything that you were digging up on the moon, because we humans. Yeah, we can make big holes in the ground, some of which are very ugly indeed. But in terms of the dimensions of a planet or a satellite like the moon, they make no difference to the physical parameters. They're more likely to affect the atmosphere, with things like fossil fuel burning and things of that sort. That's definitely a global effect. But the rotation of the planet, its orbit and things of that sort has no effect at all. So that actually covers off the first two of Monique's questions.
Yeah, I suppose you'd have to bring back a massive amount of material, like, a huge percentage of the moon's mass would have to be removed and put on Earth to make any difference, I would imagine.
Yeah, and
that would be physically impossible, yeah.
In terms of any kind of conventional sort of space flight, that's absolutely right. So what's more likely to happen is that what you mine on the moon, you use on the moon, whether that's minerals for fabrication and maybe fabrication of spacecraft parts. This is one of the things that people envisage with asteroid mining, that if you find metals on an asteroid, then you can basically use those in space to build bits of spacecraft which always stay in space, so you don't have to take things back to Earth, make them, and then put them back into space.
And like science fiction, I envisage a time where mega spacecraft are going to be built in orbit.
Yes, that's right. And I think I'd agree with that. I think that's actually our future in space. In fact, I'm a great believer in large rotating, self-gravitating spacecraft for long-term habitation by humans. I think it's a much better idea than taking over Mars, for example, and actually a bit more controllable. But that's a different story. The other thing, though, and so yes, that kind of covers off the final one of Monique's questions. How would they even think about bringing this mined goods back to Earth, as it's already a dangerous mission getting humans back into our atmosphere? Absolutely right. So most of it you use either in space or on the moon. But maybe the more significant resource that's on the moon is actually water ice, because that is itself a very, very valuable commodity in space. And water, we know, exists in hydrated rocks on the moon, but also in the moon's poles there are craters which never ever see the sun, and are known to have reserves of simply ice in the bottom of them. Now, if you could use that ice to make water, which is a very simple process if you've got the heat, you need solar radiation, of course, but you can also electrolyze it. You can decompose it into oxygen and hydrogen atoms, which gives you rocket fuel. So ice is a very valuable commodity for the idea of further exploration of the solar system, because the moon's gravity is much less than the Earth. If you can get the water from the moon, turn it into rocket fuel, you don't have to lift it off the Earth's surface. And that makes things much, much easier for journeys to Mars, for perhaps future spacecraft to the asteroid belt and beyond.
Yeah.
That's, it is a real possibility. And I think maybe in 20 or 30 years, we'll be seeing water extraction from the poles of the moon, and that water being used to propel us to the outer regions of the solar system.
Amazing. because you don't have to go to the moon to get rocket fuel. I've got a liquor cabinet, and everybody's welcome.
Different kind of rocket fuel.
Yeah.
And once social distancing is over, we'll all be there, Andrew.
Yes, indeed. Yes. Monique, thank you for the question. She was a bit worried that it would sound dumb, but no, it opens up so much dialogue. And I suppose one thing I did mention that her question prompted in my mind is ownership. I mean, you can't just go up there and start digging holes, really. No one owns the moon, and there's treaties in place that are supposed to protect all these things. But there are question marks over that at the moment because of the race back to the moon for all these reasons.
Although those are being dealt with, Andrew. So you're absolutely right that nobody can own the moon. That's embodied in the Outer Space Treaty of 1967 and its 1970s addenda. But there has been recent legislation passed, certainly in the USA, I think in the UK, and also Luxembourg, which basically says that if you go to the moon, dig up something and bring it back, then it's yours. Even though you can't stake a claim, you can't say, well, this bit of the moon's mine. But if you go and bring stuff back, then that belongs to you. And it's a pragmatic outcome based on, I guess, mainly the experience of NASA bringing back 380 kilograms of rocks and soil from the moon in the 1960s and 70s.
It's not a new concept, Fred, because that was exactly how the gold rush worked.
Yeah, that's right. Yes, yeah. And so, and in a sense, that kind of sparks a space race because you can't lay claim to any of it, but you can bring stuff back from it. So it means you've got to get there. And the same is true with asteroids as well. It would, you'd have the same sort of deal with an asteroid.
Fascinating. All right. Thank you, Monique. Great question. I do have one more question without notice, Fred. And lo and behold, you're going to be shocked, but I can answer this one myself.
Terrific.
Yeah, this one came from Twitter. While listening to episode 200, did I hear a willy wagtail at the start of the program? Yes, you did. You did indeed. And for those who are saying, what the hell is a willy wagtail? It's a small black and white Australian native bird. It's an insectivore, and it has a long, slender, rigid tail, which it wags, and it's designed to stir up insects. So it wags its tail and then spins around and catches the insects. And that's why we call it a willy wagtail. I don't know its biological name or zoological name. It's probably something much more complicated than willy wagtail. But yeah, they're a lovely little bird, and they have this very nice sort of little twitter, and it's quite piercing. And yes, our microphones, or Fred's, I think it was, picked up the willy wagtail in our last episode. There you go.
There is one hangs around outside my study window, which is probably.
And they're very, very territorial.
They are.
They'll go at anything. Which reminds me, the other day, last Friday, I was standing at the front of my place and I saw what I thought were 5 crows flying high in the sky. And as they got closer to me, I realised they were 5 wedge-tailed eagles. Now, you never often see eagles in groups of more than 2. So there were 5 of them. But my neighbourhood magpie saw them too, and he went after them and he caught the tail ender. And then the funny thing was he came back all proud of himself, did a victory swoop, believe it or not, Fred. But as he landed on the lamppost out the front of my house, he got attacked by a peewee. I just stood there gobsmacked watching all these birds go at each other. It was just remarkable. Nature at its best.
It is fantastic. And just a postscript, Ripidura leucophrys, I think is the way it's pronounced. That is Willy Wagtail. I would have thought Willius Wagtailus would have been.
Yeah, I'd be happier with that. or just Fred.
Yes.
All right, we're going to wrap it up. Thank you, Fred, so much. It's been great fun as always.
Good to talk, Andrew, and we'll speak again soon.
We will indeed. Fred Watson, Astronomer-at-Large, part of the Space Nuts team, as are you, and thank you so much for listening. And we do enjoy your comments and your questions and any input at all. on whatever platform. And we do look forward to your company again. From me, Andrew Dunkley, signing off. We'll see you next week on another edition of the Space Nuts Podcast.
Space Nuts. You've been listening to the Space Nuts Podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.